Systems Lesson 5 called Greatest Common Factor and Least Common Multiple in the Real World. So this lesson is going to be a continuation of Number Systems Lesson 4. In Lesson 4, we simply found or identified the greatest common factor and the least common multiple. Today we're going to take that a step further and we're going to be working with greatest common factor and least common multiple in real world situations. So situations we would see maybe in everyday life. So our learning target is I can find the greatest common factor of two numbers less than or equal to 100. Now, this learning target just says greatest common factor, but today we're also going to be dealing with least common multiple. So right here we have a Venn diagram. In today's lesson, knowing the words that are going to be used and whether they identify with greatest common factor or least common multiple are going to be really important. So you will see on this following slide right here, it says sort the following words into the correct categories. So we're going to be looking at these words. You're going to maybe have to kind of go back and forth a little bit, but we're going to be identifying which one of these best fits into the categories above. So let's get started. The first one says greatest. Well, obviously, greatest is going to have to go in the category that says greatest. So we are going to write greatest in that category. Now let's look at our next one, largest. Well, greatest and largest mean the same thing. So if it's asking us to find the largest of something, that's also going to be a greatest common factor problem. Next one is smallest. So smallest and least would go together. Okay, the next one is time. Now, when we're talking about time, because time counts on, this is going to be a least common multiple because multiples, right, after 2 minutes, after 4 minutes, after 6 minutes. So we're getting those multiples of numbers. So time is going to fit under that category. Okay, our next word is biggest, and that is obviously just another synonym for greatest, largest, biggest. Okay, we have least, which is going to go in the least common multiple category. Hey, we have to divide. Now, if this is talking about we're dividing things up among people. So they're not going to get multiple of it. We're going to have to split them up. So this is going to be in the, sorry about that, in the greatest common factor one. Okay, arrangement. So again, this is kind of like dividing. We're going to arrange something into groups. So that one's going to fit in here. Buy or get multiple things. I don't know why it says things twice, but there you go. Buy or get multiple things. So again, multiples of something are going to go in the least common multiple. So buy or get multiple things. And I'm just going to, for the sake of our space, I'm just going to put buy multiple. Okay, most. We know most, right? If we're going to find the most of something, we want the greatest. So that's going to go over here. Split into smaller parts. So that's the same as dividing something up, right? So that's going to go over here, and I'm just going to write split. Our next one says find something that happens at the same time. Now again, time. Time counts on, right? Every 5 minutes, every 10 minutes. So that happens at the same time is going to go over here in our least category. I'm just going to put same time. And some of these will make more sense when you see them in a real world situation here in a minute. Okay, arrange something into rows and groups. So we know arranging already goes with our greatest. So this one we're going to arrange it into groups. Find an event that repeats over and over. So if something's repeating over and over, right, it's going to happen now and then again and again. So that's going to be a multiple, right? Because it's happening at a different time each time. So that one repeats is what we're going to put. Now, there weren't any words for common, but if we think about it, and we think about like what else can mean the like in common, right? So I'm going to write down same because same means it's in common. We could write identical, right? Because that would mean it's in common or similar. So those type of words will be used there. So let's dive in and look at what this would look like when we get a real world situation. So here we go. Two brothers, Luke and Jake, are working together at Kent's Deli today. Luke works every 9 days and Jake works every 12 days. How many days do they have to wait until they next get to work together? So if we go back up, okay, here's that chart we made. And we're looking, are we splitting something up? Right? Are we breaking it? Or are we arranging it? No, this says that someone's doing something every 9 days and every 12 days. So to me, that's right here. It's an event because they're working and it's going to repeat over and over, right? It says Luke's every 9 days, Jake every 12 days. So we're going to be finding the least common multiple when we're doing this. So let's go back and think about what we learned yesterday in number system lesson 4. Right? We're going to write down our two numbers, our 9 and our 12, and we're going to create our ladder. So a number that goes into 9 and 12 we know is 3. 9 divided by 3 is 3. 12 divided by 3 is 4. We're going to look right here. 3 and 4, do they have any common factors? Nope. Now, least common multiple, remember, we make that L, and then we multiply. So 3 times 3 is 9. 9 times 4 is 36. So how many days do they have to wait until they next get to work together? They're going to wait for 36 days. Now, let me show you how this works, right? If we think about it, Luke works on the 9th, then he will work again the 18th, then the 27th, and then the 36th. Sorry, it's cutting off. And Jake works on the 12th because I'm doing multiples of 12. Well, the 24 and 36 days. So look at that. That 36 is what we found right here. Okay, let's look at the next one. Sean has 39 pairs of headphones and 13 music players. He wants to sell all of the headphones and music players in identical packages. What is the greatest number of packages Sean can make? So we're looking for those keywords, and I found it right here. greatest number of packages. Okay. So obviously, if it's going to tell us to find the greatest number of something, we're going to find the greatest common factor. So let's take our two numbers, 39 and 13, and create our ladder. So I need a number that goes into 39 and into 13. Well, they're not both even, so I can't use 2. I look at 13. I know 13 is a prime number, so the only thing that goes into 13 is 1 and 13. Oh, but I know that 13 times something is 39. So 39 divided by 13 is 3. 13 divided by 13 is 1. So it's asking us for the greatest number of packages. So greatest common factor, I just take what's out front. This tells me that he can put together 13 packages if he wants them to be identical. Hey, let's try another one. Tammy's Stationery sells thank you cards in packs of 9 and birthday cards in packages of 4. Surprisingly, the store sold the same number of each type of cards this month. What is the minimum number of each card type that the store must have sold? Hey, we got to find our keyword. And in this case, minimum number sounds just like minimum and least. So we are going to find our least common multiple. Now, let's look. It says, what is the minimum number of each card type? So we're going to have to do a little bit more, but let's start off with our least common multiple. So we have 9 and 4. Is there anything in common in 9 and 4? No, the only thing I can think of is a 1. So really 9 divided by 1 is 9. 4 divided by 1 is 4. Least common multiple, I make my L. Now, did I really need to put that 1 out front? No, but it kind of helps with the process. So 1 times 9, 9. 9 times 4, 36. So we always have to ask ourselves, though, does that answer my question? What is the minimum number of each type that the store must have sold? Well, if thank you cards come in packs of 9, can 9 get to 36? Yeah, 9 times 4. And if birthday cards come in packages of 4, we could have bought 9 because 4 times 9 is 36. So we must have bought 36 of each card in order to have the exact same, the identical. Okay, let's look at this one. A family is preparing backpacks filled with school supplies to donate to children in need. They have 18 pencils and 3 notebooks. If they want to make all the backpacks the same, with no school supplies left over, what is the greatest number of backpacks they can fill? So let's look at this. Our keyword again, I see greatest. So I'm going to be finding greatest common factor. So 18 and 3, I create my ladder. What goes into 18 and into 3? Well, 3. 18 divided by 3 is 6. 3 divided by 3 is 1. I look at my 6 and my 1. Nothing else in common. So, what's the greatest number of backpacks they can fill? Right there. They can fill 3 backpacks. Now, it's asking how many pencils will be in each backpack. Well, if I look up here, I had 18 pencils. And I'm putting them in 3 backpacks. So over here, right, 18 pencils, put in 3 backpacks, gives me how many in each? 6, because 18 divided by 3 is 6. Now, 3 notebooks is all I have for this next question. How many notebooks will there be in each backpack? I only have 3 notebooks right here, and I'm putting them into 3 backpacks. How many are going to be in each? Only 1. let's have you try this next one. So pause your video, go ahead and try it, and when you're done, come back and we will go through it. Okay, Jordan is setting out Korean food for a party he is having. He has 6 avocado rolls and 9 cucumber rolls. If he wants each plate to be identical with no rolls left over, what is the greatest number of platters Jordan can create? How many avocado rolls will be on each plate? And how many cucumber rolls will be on each plate? So, again, I see a keyword, greatest number. It's nice when we see that greatest number because it tells us we're going to be finding the greatest common factor, or the GCF. So we have 6 and we have 9. We create our ladder. What goes into 6 and into 9? 3. 6 divided by 3 is 2. 9 divided by 3 is 3. Now I want greatest common factor, so I just take the number out front. What's the greatest number of platters that Jordan can create? 3. Now, follow-up question. How many avocado rolls will be on each plate? Well, how many avocados do I have? 6. And 6, right here, split on 3 plates would give us, look at this, 2 on each plate. Okay, cucumber rolls, so I have 9 of them, right here, 9 of them, split onto 3 plates. Well, 9 divided by 3 is 3. So 3 cucumber rolls on each plate. Okay, go ahead and try this one. Pause your video. And when you're done, press play and let's talk about it. Okay, Brian and Justin are playing games at their local arcade. Incredibly, Brian wins 5 tickets for every game, and Justin wins 11 tickets for every game. When they stopped playing, Brian and Justin had won the same number of total tickets. What is the minimum number of games that Brian could have played? So, I have some key things I'm looking at here. It says identical. Remember, we talked about identical. Or not identical. It says the same. Sorry. The same number of total tickets. So common, right? And minimum number. So is minimum least common multiple or greatest common factor? Well, minimum and least go together, synonyms. So we're going to be finding the least common multiple. So 5 and 11, we have our ladder. So what goes into 5 and then into 11? Wow, only 1. So do you remember the one we did? We had a 1 here. And then 5 divided by 1 is 5. 11 divided by 1. So if there's only a 1 in common, what are we simply doing? We're simply multiplying, right? Because 1 times 5 is 5. 5 times 11 is 55, right? We multiplied what was in that L. But if there's only 1 in common, we can just multiply those two numbers because our 1 out front is not going to change our problem. So we know that they had the same number of total tickets. And how many tickets did they have? 5. Now, what is the minimum number of games that Brian could have played? Does this answer the question? Could he have played 55 games? No. We know that they had 55 tickets. So we got to figure out how many games did he have to play. And it says Brian wins 5 tickets every game. So how many games did he have to play to get to this 55? Well, 5 times something has to give me that 55, and I know 5 times 11. So he had to play 11 games. So this is our final answer. But be careful on those. Don't always just take the least common multiple or the greatest common factor and think it's that's our answer. We have to answer the question. Okay, he didn't play 55 games. That would be a long time at an arcade. He played 11 games. Okay. Katie is buying flower bulbs for her garden. She wants to buy the same number of tulips and daffodils. If tulip bulbs come in packs of 11 and daffodils bulbs come in packs of 17, what is the least number of each type of bulb Katie will need to buy? So she wants to have the same. We can see that. Right? So she wants to have the same, the in common. And what's the least number? So hopefully that tells you least common multiple, right? Go ahead and try this and then press play when you have completed this problem. Okay, we have 11 for tulips and daffodils come in 17. So here's something I know about 11. I know 11 is prime. And so I know the only factors are 1 and 11. And I also know 17 is prime. 1 and 17. So the only thing in common, if you want to pull it out, is a 1. 11 divided by 1 is 11. 17 divided by 1 is 17. Least common multiple, right, is that L. So I multiply. 1 times 11 is 11. 11 times 17. So 17 times 11. 1 times 7, 7. 1 times 1, 1. I put a 0 placeholder because I'm now in the tens place. 1 times 7, 7. 1 times 1, 1. So 7 plus 0, 7. 1 plus 7, 8. And 1 plus nothing is 1. So let's see. We have 187 right now. And what is the least number of each type of bulb Katie will need to buy? Well, she has to buy at least 187 of each bulb so that she has the same number of tulips and as daffodils. Hey, Kara has 12 forks and 18 knives to place in silverware holders at the fast food restaurant where she works. She wants to distribute them equally with no forks or knives left over. What is the greatest number of silverware holders Kara can stock? And then how many knives and forks will be in each silverware holder? So pause and try it. Okay, let's check your work. So hopefully the first thing you did is you found that most important word right there, that greatest number of something. So greatest common factor. We have 12 and we have 18. I create my ladder. What goes into 12 and into 18? Well, I could actually use a few things. 12 and 18, I'm going to pull out a 6. 12 divided by 6 is 2. 18 divided by 6 is 3. Now, you could have done 3. You could have pulled out a 2. In the end, though, you still will get the same thing. So, anything in common in 2 and 3? Nope. So, what is my greatest common factor? 6. So, what's the greatest number of silverware holders Kara can stock? 6. Now, how many knives will be in each one? Well, let's look up here at knives. There's 18 knives. So 18 knives, right, which is right here, split into 6 packages or 6 silverware holders gives us 3 because 18 divided by 6 is 3. So there's going to be 3 knives. And let's look at forks, 12 forks. Well, 12 split into those 6 is going to give me 2 because 12 divided by 6 is 2. So there's going to be 2 forks. Go ahead and try this one and then press play when you are ready. Diane is planting 4 bushes and 6 trees in rows. If she wants all the rows to be exactly the same, with no plants left over, what's the greatest number of rows Diane can plant? We got our keyword. If you notice, some of these keywords seem to show up quite a bit. What's the greatest number? So, greatest common factor. We have 4 and we have 6. Create our ladder. What goes into 4 and into 6? 2. 4 divided by 2 is 2. 6 divided by 2 is 3. So what's the greatest number of rows she can do? She can do 2 rows. Now, follow-up question. How many trees and bushes will be in each row? So, how many trees do we have? We have 6 trees. Put in 2 rows. How many will be in each? Well, we just divide, right? 6 divided by 2 gives us 3 trees. And how many bushes? 4. 4 bushes split into 2 rows gives us 2 bushes per row. All right, try this one. Okay, Dax enjoys bird watching and observed 2 types of birds traveling this season, ducks and seagulls. While the ducks traveled in flocks of 5, the seagulls traveled in flocks of 9. If Dax observed the same total number of ducks and seagulls, what's the smallest number of ducks that he could observe? So, keyword again, what's the smallest number? So we're finding least common multiple of 5 and 9. Ooh, if we look at this one, what goes into 5? 1 and 5. So this is going to be one of those, again, that the only thing in common is 1. 5 divided by 1 is 5. 9 divided by 1 is 9. We have our L. 1 times 5 is 5. 5 times 9 is 45. So let's go back to our question. What's the smallest number of ducks that he could have observed? Because we know he observed the same total number of ducks and seagulls. So he had to have observed 45 ducks and 45 seagulls. So this does answer our question. Okay, couple more. Go ahead and try, and then check your answer. Bree just received 2 separate gifts from her great-great-grandmother. The first gift is a box of 18 chocolate candy bars, and the second gift is a box of 12 cookies. Bree wants to use all of the chocolate candy bars and cookies to make identical snack bags for her cousins. What is the greatest number of snack bags that Bree can make? How many candy bars and cookies in each bag? So, keyword again, what's the greatest number of snack bags she can make? So we're going to be finding greatest common factor of 18 and 12 with a ladder. What's in common in 18 and 12? I'm going to say 3. 18 divided by 3 is 6. 12 divided by 3 is 4. Oh, 6 and 4 have something in common. 2. 6 divided by 2 is 3. 4 divided by 2 is 2. 3 and 2 don't have anything in common. So greatest common factor, remember I take what's out front and I multiply. 3 times 2 is 6. So what's the greatest number of snack bags that Brie can make? 6. Now candy bars. Let's go up here. She had 18 of them. She's splitting them into 6 bags. 18 divided by 6 is 3. So there's going to be 3 candy bars in each bag. Cookies, there's only 12. 12 of them split into my 6 bags is going to give me 12 divided by 6 is 2. So 2 cookies in each bag. Right? And it's important that you label, because if we just put 3 and 2, we don't know which one's which. Okay, last one. Chloe is preparing dinner plates. Here's 8 pieces of chicken and 4 rolls. If she wants to make all the plates identical without any food left over, what's the greatest number of plates Chloe can make? There's our keyword again. What's the greatest number? So let's make our ladder. What goes into 8 and into 4? Well, I know 4 does. 8 divided by 4 is 2. 4 divided by 4 is 1, nothing else in common. So greatest common factors, what's out front? So what's the greatest number of plates she can make? She can make 4 plates. Now, how many pieces of chicken will be on it? Well, how many pieces of chicken does she have? 8. Put on 4 plates. Everyone gets 2 pieces of chicken. And how many rolls? Well, there's only 4 rolls. Put on 4 plates. 4 divided by 4 is 1. So everyone gets 2 pieces of chicken and 1 roll.